I just discovered something that's about to change everything for YouTube creators. So there's a new AI automation system that's allowing people to build real audiences off of completely automated content. But here's what nobody's talking about. While other creators are spending like 20+ hours per video, there's a way to automate the entire process in less than 5 minutes of actual work per video. Now, I can hear what you're thinking. This has to be expensive, right? Or this must require a lot of coding skills. Well, here's the shocking truth. The entire system costs less than 50 cents per video to run. It uses zero code and can pump out monetizable long-form content every hour. So I'm going to show you exactly how to build this system using N8N. I'm going to walk you through every single node, and I'm going to prove to you that mastering AI automation might be the most valuable skill you can learn right now. So take a look at this Bigfoot, Bigfoot vlog channel that's created with AI. We're gonna do the same exact thing with our own automation. So let's go ahead and dive in. So when I first set out to create 100 long-form YouTube videos with no code, I wanted to see if it was really possible to automate everything from the ideas to the uploads using AI. Now, before we jump into building anything, let's actually see what we're working towards. Because it is one thing to talk about automation, but it is a lot easier to understand once you've seen it running in real time from start to finish. So in this demo, I'm going to show you exactly what happens when the workflow goes live, how a few rows in Google Sheets turn into full AI generated videos that upload themselves to YouTube and update automatically behind the scenes. And once you've seen it in action, we'll go back and we'll break down how to build every single part of it step by step. We'll begin here in Google Sheets, which acts as our control center for the whole process. And here, every row represents one video project, and every column holds the details that will guide the AI generation. Now, if you don't have your data set up yet, we can generate it instantly with ChatGPT. Simply prompt it to create a table with columns for ID, title, caption, story idea, channel description, character, visual style, image reference, scenes, aspect ratio, production status, and final out. This gives you a clean, structured foundation that the automation can read line by line. Once your data is in place, set the production status for all of the rows to in production. This is how N8N knows which videos are ready to process. So when you hit execute workflow inside N8N, the system automatically reads your sheet, pulls the relevant data, and then starts generating content using Kai AI for image and video creation, and JSON to video for full video assembly. It handles everything from scene generation to media rendering, all completely hands-free. After execution, we can verify the results across 3 places. In Google Sheets, you'll notice the final output column updates with URLs or completion statuses for each processed video. In Google Drive, the rendered files appear neatly stored in your chosen folder. And finally, of course, over on YouTube, your generated videos will show up on your channel, usually marked as unlisted by default. And in just a few clicks, we've taken a spreadsheet of text and turned it into fully published video content, ready to scale, repeat, and automate again and again. All right, so let's finally start building out our automation. Now, the first thing we need is a way to make the workflow run on its own. No manual clicks, no reminders. So here we'll be needing the on-schedule trigger. It automatically starts the workflow at set intervals, keeping our system running in the background while we focus on other tasks. So let's start by adding an on-schedule trigger node here. This node activates the workflow automatically based on the schedule that we choose. Next, let's set the trigger type to day so it runs once every day. Then set the interval to 1, which ensures the workflow executes daily. Perfect for automated content or video generation. And finally, let's click Execute Step to test the trigger and make sure it's working properly before we move on to the next part of our build. Now, every automation needs a reliable source of truth, and in our system, that's Google Sheets. It's where all the ideas, the captions, and production details live. In this part, we're going to wire the workflow to our sheet so it knows exactly which project to work on next. It's like giving the automation a live to-do list it can pull from automatically. We'll start by adding a Google Sheets node here to our workflow. Now, this connects N8N directly to our spreadsheet, letting it read all structured video data. Once it's added, we'll select our Google Sheets credential to securely authenticate access. Now after that, set the resource to Sheet within Document, then pick the file where our video list is stored. Let's make sure that our sheet includes these columns: title, caption, story idea, channel description, character, visual style, colors, special request, voice ID, image reference, background music, scenes, aspect ratio, production status, and final output. For this demo, I'm setting scenes to 5 just to keep things simple. Next, let's add a filter so the workflow only grabs rows that are ready to be processed. Set field to production status and value to create. Then toggle on return only first matching row to make sure it handles one entry at a time. And that way it doesn't try to generate multiple videos at once. Finally, click execute step to test the setup. If it returns a single row where production status reads create, that means everything's working perfectly and our workflow can now pull new video data straight from our sheet every time that it runs. Now here's where the automation gets creative. Once the workflow pulls data from our Google Sheets, we're going to use AI, of course, to turn those details into actual video content, complete with scenes, visuals, and dialogue ideas. Now this is the brain of the system, where the text from our spreadsheet becomes a structured cinematic direction that tools like JSON to video can use later on. Now first, we need to add an AI agent node. This is what handles all the creative heavy lifting for us, generating the scene breakdowns, image prompts, and the dialogue. It's what turns our structured data into storytelling material that the rest of the automation can follow. Then we'll set the user prompt to define below, click the expression icon, and paste the prompt we wrote earlier in ChatGPT. Now here, we'll feed in context, the title, the story idea, the character, and visual style, so the AI knows exactly what kind of video it's building. Next, let's move on to the system message. Click expression again, and paste the one we generated in ChatGPT. Now this part sets the tone for the AI. It tells what role to take and how to respond. So for example, you are an AI creative assistant that generates scene breakdowns, voice text, and image prompts for cinematic short videos. After that, turn on Require Specific Output Format to keep the AI consistent. This ensures that we always get clean, structured results instead of messy or incomplete text, making the output ready for automation right away. And from there, let's set the model to Gemini and select Gemini Flash Lite. It's fast, reliable, and performs especially well for creative, structured text generation. Then add an output parser tool and select Structured Output Parser. You'll see the exact schema for this part on your screen. It's what organizes and formats our data so that everything stays readable and usable in later steps of our workflow. To finish this, let's head on over to the Settings tab, toggle Retry On Fail on, and set the retry delay to 3000 milliseconds, 3 seconds. Now this small buffer helps the workflow stay stable by automatically retrying if a request ever fails, keeping the entire process smooth and uninterrupted. And once everything's ready, let's click Execute Step to test it out, and you should see structured data for each scene, complete with image prompts and voice text that we can feed straight into the next part of our workflow. And now that it looks pretty good, rename the node to Generate Scenes and Prompts. Now doing this keeps our whole build nice and neat and easy to manage. Right now, the AI has generated all the scenes and prompts together in one bundle. But before we can create visuals or voiceovers, we do need to split that output into individual pieces. Each scene has its own text, dialogue, and image prompt, so breaking them apart makes it easier for the next steps to process everything independently. Now what we'll do here is add a split out node. This node takes all the group data from the previous step and then separates it into individual workflow items. It's what allows each scene to be handled on its own later on, whether that's generating an image, creating a voice track, or building a short clip. Next, we'll drag the array output from the Generate Scenes and Prompts node into the Fields to Split Out box. Now that's how you tell N8N which part of the data structure to separate. And once it's set, we'll click execute step to test it out. And if everything works out, you'll see one execution per scene in the data preview, meaning the workflow is now ready to handle each moment of your video separately. Now that each scene is separated, we'll save those details into a new sheet so that everything stays organized. And doing this gives us a complete record of every scene the AI creates, including the titles, the image prompts, and the voice text, and it's all stored neatly in one place. Just think of this as our production log, where every generated element is tracked for easy reference later. We'll start by duplicating the recent Google Sheets node, and copying it just keeps the same credentials and file reference, so we don't have to reconnect anything from scratch. It also ensures that the data stays linked to the same document that we used earlier. Next, change the operation to append row. This tells N8N to add new rows instead of pulling existing ones. Each generated scene from the AI will now be inserted as a new entry. Then we'll change the sheet to sheet 2. This keeps your generated scene data separate from your main control sheet, helping us stay organized and preventing any accidental rewriting or overwriting of the original metadata. Now drag the inputs from the split out node into their corresponding fields, things like ID, title, caption, scene number, image prompt, voice text, and video prompt. Leave image reference and video output empty for now, as those will be filled in by later steps. Now, if everything is mapped out already, you can click execute step to test it out. Check sheet 2 in Google Sheets to confirm that the new rows have been added and that all scene details appear correctly. And just like in the earlier steps, we have to rename this node to add scenes and prompts to keep our workflow clear and easy to navigate later on. All right, so now we've got the prompts, and now it's time to turn them into visuals. Using Kai AI's Seedream API, we'll generate images automatically for each scene, giving our project real cinematic material to work with. These images will later be used for our video builds or quick previews, depending on how we set up these next steps. So we'll start by adding an HTTP request node and then renaming it Generate Images. This is what sends the call to Kai AI's API and then brings the generated visual straight into our workflow. Now, from there, we're gonna head on over to Kai.ai. We're gonna open up the AI image API page and select Seedream. We'll scroll down to the example request, copy the curl command, and then bring it back into N8N. Inside N8N, we'll open up our HTTP request node. We'll click import curl, paste in the command, and then hit import. That automatically sets up the endpoint, the headers, and the basic configuration so that all we need to do is adjust the details. Now we'll grab our API key from the Kai AI dashboard and we'll replace the placeholder token in the authorization header with our own key. Then in the send body section here, we'll update the prompt field to reference the image prompt from our previous node. We'll adjust the image size to landscape 16:9 to give it a cinematic frame and keep everything consistent with our video format. Now, when that's ready, we'll just do like usual. We'll run a quick test by clicking the execute step button. And if everything's set correctly, we'll see image URLs or base64 data appear in the response preview. And that is the proof that our visuals are generating successfully. Again, we'll go ahead and rename the node to Generate Images to keep things organized and clearly mark where our workflow starts creating the real visuals. Now, before moving on, it's a good idea to give Kai AI a moment to finish creating all the images. Why? Well, because this quick pause helps to make sure that every generated visual is ready before the workflow tries to use or upload it, avoiding errors or missing files later in our process. So this is what we're gonna do. We'll add a wait node by clicking the plus icon here and selecting wait in N8N. Then set the duration to 2 minutes. Now, this short delay acts as a buffer, which will give Kai AI enough time to finish processing all image requests in the background. And this will keep our workflow stable and prevent it from jumping ahead too early. Once the delay runs, the next nodes like uploading to our Google Drive or generating processing videos will have everything that they need to continue on smoothly. After giving Kai AI a short buffer to finish processing, it's time to pull the final images back into our workflow. And here we'll make sure that we are actually retrieving the completed visuals, the real URLs that we're going to use later for uploading or turning into video scene. To fetch them, we'll add an HTTP request node and rename it Get Images. We'll head over to the Kai AI Seedream API documentation and we'll scroll to the query task section here. There we'll find a sample curl command. We'll copy it and then bring it into N8N. Open our new node, click import curl, paste the command, and then hit import. Doing that automatically sets up the base configuration for us. Next, we'll adjust the details to connect it to our workflow. In the URL, replace the task ID with the one coming from our previous node using an expression so it dynamically fetches the right task every time. Then we'll go to the authorization header and swap out the placeholder key with our own Kai AI API key from the dashboard. Now, I think everything looks good here already, so we'll go ahead and click execute step to test it out. And we'll know it worked when the response shows our image URLs and a completed status in the metadata. And from there, we'll label the node Get Images again, so it's easy to spot when we wire these links into storage or the video build steps next. So given that the images have already been generated and retrieved, our next step is to record them properly. We'll update the Google Sheet so that each scene has its own image link from Kai AI, keeping everything for us organized and easy to track later when we start building out videos. To do that, we'll duplicate our most recent Google Sheets node here, the same one that we used earlier for adding scenes and prompts. We'll right-click it, we'll select duplicate, and then connect it directly after the Get Images node so that the flow continues smoothly. Next, we'll change the operation to update row, and under column to match on, select scene number. This tells the workflow exactly where to place each image URL. We'll drag the scene number from the Add Scenes and Prompts node into the matching field so that the system knows which row to update. From here, we'll keep only the image reference field active. And for its value, we'll paste the expression shown here on your screen. This automatically parses the Kai AI response and extracts the first image URL from the JSON output. Before running the test, we'll take a moment just to clean things up here, and we'll remove any unnecessary columns so that nothing important gets overwritten. And once everything looks good, we can go ahead and proceed to, again, clicking the execute step to test the update. And if everything runs correctly, we'll open our Sheet 2 and we'll see each scene neatly paired with its image link under the image reference column. Now that confirms our process worked perfectly. Again, we'll just rename the node Add Image Reference so that it's easy to recognize when we're reviewing or expanding our workflow later. So everything up to this point so far has been leading to this, the moment where our workflow actually starts producing full videos. Using Kai AI's VO3 model, we're going to combine our generated images, our scene prompts, and our dialogue into cinematic clips that actually feel complete. Now this is where the data turns into motion. To make it happen, let's add an HTTP request node right after the Add Image Reference node, and then rename it Create Video. Now this node connects directly to VO3 and it handles the requests that tells the model what to generate. Now we'll find this setup inside our Kai AI dashboard. Under Models Market, we'll open up VO3, we'll click the API, and we'll copy the same curl command. Import that into our N8N node, we'll just paste it in, and everything from the URL to the headers will be configured automatically. And from here, we'll replace the placeholder key in the authorization header with our actual Kai AI API key so that our workflow can access our account. In the Send Body section, we'll use the expressions, again shown here on your screen, to connect your scene data. Now the prompt pulls in your video prompt, your voice text, and your image reference from the earlier steps, telling the AI exactly what to render. And we can adjust the aspect ratio or remove optional fields if we want to simplify the request. And once it's ready, we'll click Execute Step and then let VO3 do its thing. The generation might take a few moments, but once it is done, we'll see a task ID or result URL in the output, proof that our video was successfully created. And from there, all that's left is to name the node create video. So again, everything stays organized as we move toward the upload stage. Now, before pulling the generated videos, we do need to make sure that Kai AI's Video 3 model has enough time to finish processing. And the videos can take a few minutes to render, so this pause ensures that everything is ready before the workflow moves on. And doing that prevents failed requests or incomplete downloads. So let's add a wait node right after the create video node and then set the wait time to say 5 minutes. This gives the API enough breathing room to complete video rendering in the background before the next step runs. When we test it with execute step, it will show it's completed instantly, but during a real workflow run, this node will hold the process for the full 5 minutes that we set earlier on. We'll rename it to wait for video generation so it's clear what this delay is for when reviewing or adjusting our workflow later. After giving Kai AI enough time to finish rendering, we are now going to pull the completed video details back into our workflow. This will confirm that the video task is done and retrieves the final link that we'll use for uploads, previews, or later automation steps. We'll begin by adding an HTTP request node right after wait for video generation so that everything flows smoothly. In your Kai AI dashboard, head on over to Models Market, open up Veo 3, and look under the API section for Get Veo 3 Video Details. Then copy the sample curl command from there and then import it back into our N8N node. And doing that will instantly set up the correct endpoint and headers without needing to type anything in manually. Once imported, we'll enable send query parameters and add one called task ID. We'll link it to the task ID coming from the previous step. That's how the system knows exactly which video to fetch. Then check the authorization header and replace the placeholder with our actual API key in the format bearer your API key. Give it a test run by clicking execute step, and we'll see a response containing our video's metadata, including the finished video URL inside the result JSON. And from here, we should rename the node to get video to keep all things organized as we move on to the next part of our automation. Now, after the video has been successfully generated and retrieved, it's time to send that information back to our control sheet. Now, this part ties everything together. Each scene now gets its own video link, creating a full record of our workflow output from prompt to final render. Now, to do that, duplicate your add image reference node and place it right after the get video node so that the process stays in sequence. Keeping the same credentials ensures that our data connects to the same Google Sheet without any extra setup. Then we'll switch the operation to update row if it's not already, and then we'll set the column to match on to scene number. Now, this makes sure that every video is matched with the correct scene entry. Now, from the add scenes and prompts node, we'll pull the scene number so that the right row gets updated. Next, clean up the fields by removing image reference and adding a new column called video output. For its value, we'll use the expression shown here on your screen. It extracts the video URL from the get video node and then assigns it to the matching scene. So we'll run the node to test the setup, and if everything's working, your Sheet 2 tab in Google Sheets should now display valid URLs under the video output column. And that gives you a complete reference sheet for every step of our workflow, ready for archiving or reuse in future runs. Now, you know this part by now. We'll rename this node add video output to keep our structure clear and consistent moving forward. All right, so before we move to the compilation stage, we first need to gather all the generated video entries tied to a specific title. And this step pulls every related video output from our Google Sheets, ensuring that the workflow collects everything needed for merging or post-processing later on. Now, this is what we need to do. We'll duplicate the add video output node here and then place it below the previous step so the sequence stays consistent. Next, we'll open the duplicated node and then switch the operation to get rows. This will tell the workflow to read data from the sheet instead of updating it. Now here in the settings, we'll set the column to video title and then map the value to the video title field from the add scenes and prompts node. This way, our workflow only retrieves rows that belong to that specific video project. Now here under additional options, we'll add one more setting and then toggle return only first matching row on if you want to test quickly with a single record. We'll run the node using execute step, of course, and check the output preview. You should see all the matching video entries appear complete with their details and URLs. We'll rename this node again to get video so it's easy to reference when we do connect it to our compilation or export flow next. At this stage, each scene has its own video output. Now it's time to bring them all together. Now, this means we'll be merging every generated video link into a single list, making it easier to compile, merge, or process everything in one go during the final stages. So we'll add an aggregate node from the data transformation section here, and we'll set the node to aggregate items. In the input field name, we'll type video output. Now this tells the workflow to collect all the video URLs from our previous nodes and then combine them into one unified list. We'll run a quick test with execute step to make sure everything's being gathered correctly. Now we should see one item in the output containing all of the video links grouped together. Again, we'll rename this node aggregate video output so that it's clear to us later what the step handles as we move on to compilation or export. After generating all of our individual clips, we're now going to turn them into a single polished video. Now, we don't have to manually edit and sync scenes precisely because we'll use JSON to video to handle the heavy lifting for us. Now, this step takes our completed outputs and then compiles them automatically into one cohesive file using a ready-made template. The very same process used by creators automating full-length content at scale. Now what we're going to do here is add an HTTP request node from the network section, and then we'll change the method to post. This node will send our request to JSON to video API. After that, we'll go to our JSON to video dashboard. We'll open the N8N tutorial page here, and under the documentation titled How to Configure Your N8N Nodes, we'll copy the API URL provided. We'll paste it into the URL field in N8N, and then we're going to enable send headers and set up authentication. Now for the header name, type X API key, then grab your personal API key from the API key section in JSON to video, and then paste it as a value. Next, go to the send body section, switch to using JSON, and then paste the JSON structure shown here on your screen. Now this maps all of our video outputs from video 1 through video 10 so that each scene is automatically placed in order during rendering. In JSON to video, open the Templates tab, create a new template if needed, and then copy its template ID. We'll replace the placeholder text with that ID in your JSON, and finally rename the node Combine Videos so that it's easy to identify later. We'll leave this one ready, but don't run it just yet. We'll trigger it once all inputs are finalized in the following step. Now, before we finally actually run the merge, we do need to set up the JSON to video template that defines how each clip from video 1 through video 10 will appear in our final output. So think of this as your editing workspace where you design the flow of the scenes, we set up transitions, and we link the placeholders to our dynamic video inputs. Once it's configured, every future compilation will follow this same structure automatically. So we'll head on over to our JSON to video dashboard and we'll open up the templates tab from the sidebar. Select the template you created earlier, the one whose ID you used in flow 16. Now inside the editor, click Add Scene, then from the left panel, drag a video element into the scene. We'll hit the pencil icon here next to the layer, and under Source, we'll choose Uploads and add a sample video just to serve as a placeholder. Then we'll adjust the layout by setting the video to scale to fit, then reload to refresh the preview. Now we'll make sure that the clip fills the full screen and add a fade out transition of about half a second for smoother cuts. Now, if that first scene already looks right to you, we'll duplicate it until we have 10 total scenes, one for each of our video inputs. Each duplicate will become a placeholder for video 1 through video 10. We'll click reload and play to make sure the timing and the transitions feel natural. Next, switch to the code view by selecting template and then edit template JSON. And here inside the JSON file, we'll locate every SRC source field and replace the sample upload links with our video variable names. So video 1, video 2, all the way to video 10. And each one should match the correct scene in order. So we'll save the template, we'll return to preview here and hit reload again. And we should now see that each scene references our dynamic variables instead of static files, so that when we hit play, every placeholder represents one of our generated clips, giving us a fully dynamic automated template ready for rendering in the final flow. Okay, so now that the template is ready, it's time to actually run the combination process and let JSON to video render the final output. And this part triggers the merge of all of our scene clips into one continuous video, then introduces a short pause so that the system has enough time to finish processing before we retrieve the result. And we're going to start by selecting the combined videos node that we configured earlier and click execute node. JSON to video will begin compiling our clips based on the template setup. You'll know it's working when a successful response appears with a task ID and a confirmation that the rendering has started. Next, we'll drag a wait node onto our canvas and connect it directly after the combined videos node. We'll set the wait duration to, let's say, 3 minutes. And this buffer gives JSON to video time to complete the video rendering without causing any errors from premature requests. And finally, we're going to go ahead and test it out by executing the wait node. It should briefly show as complete, but will enforce the delay during the actual workflow execution. And once this step is done, the workflow will be ready to fetch our compiled video in the next part of the process. Okay, so after waiting for JSON to video to finish rendering our video, the next step is to check the project status and then pull the final video details. This will verify that the compiled file is complete and provides the download link for the finished output. Now, the exact request setup is shown here on your screen, so you don't need to read any code or syntax aloud in the voiceover. Just duplicate the combined videos node from flow 16 and then drag it right below the wait node from flow 17. Inside the duplicated node, we'll change the method from post to get and adjust the URL so it points to the same project that we created earlier. And now we're going to see how that's formatted here on your screen. And since this step is only fetching data, disable send body to keep the request clean. Then we'll execute the node to check for a successful response. And if everything is processed correctly, we'll see the project metadata and a ready-to-use video download URL. Rename the node to get combined video, so again, the flow stays organized for the final export steps. Okay, so we're done confirming that our final video is ready. And now the next step is to download it from JSON to video. This step ensures that we have a local copy of the rendered file ready for upload, review, or archiving. The exact setup and the expressions are shown right here on your screen. So again, you don't need to read any code aloud in the voiceover. Now we'll add a new HTTP request node and then connect it right after the get combined videos node. We'll set the method to get, then open the URL field, and then use the video link from the get combined videos output. Once the URL is in place, we'll execute the node to start the download. Wait for the process to complete, and then confirm that binary data appears in the response. And that means the file is successfully fetched. Again, we'll rename the node download video to keep our workflow organized as we move into the final upload or the export steps. And look at that, there you go. Our final video is downloaded. And that means the next step is to just store it securely. So we'll upload the finished file straight to our Google Drive, making it easy to access, share, or archive for later use. And through this step, we'll close the automation loop, taking our fully generated content from creation to storage storage without any manual uploads. So we'll add a Google Drive node here and set the operation to upload file. Under the parent folder, choose the folder where we want all of our completed videos to be stored. So for example, AI videos. We'll see this selection clearly here on your screen. Next, we'll map the file name to the title of our project by linking it to the output from the Get Ideas node. Then for the input data field name, we'll connect the binary data coming from the download video node. That's your actual video file ready to upload. And when everything is set, we'll click the execute step and then just wait for the confirmation message showing us that our file has been successfully uploaded. And as usual, we'll rename the node to upload to drive to keep our workflow organized and ready for reuse or scaling later on. Okay, I know I said this before, but here is the exciting part. Now that our video is stored safely in our drive, publish it. This step uploads our final video to YouTube, complete with its title, its caption, and category, making it instantly shareable or ready for view. And we can even control its visibility, so it uploads as public, private, or unlisted, depending on whatever our needs might be. First, we'll add a YouTube node here and set the operation to upload a video. In the title field, we'll map the title from our Get Ideas node. You'll see how that's linked visually here on your screen. Here, I'll set the region code to PH, and I'm going to choose film and animation for our category to keep our uploads consistent. Now, under additional options, we're gonna add a description field and then map it to the caption from the Get Ideas node. Then we'll add one more option for privacy status, set it to unlisted so the video stays accessible only through a direct link. Next, we'll select our video file for upload by choosing the binary property from either the upload to drive or download video node, depending on which one contains the actual file. And once everything's configured, again, we'll just click execute step to start the upload. We'll wait for confirmation that the process is complete, then head on over to my YouTube studio to verify the video appears in my uploads list. Again, I'm gonna rename the node upload to YouTube to keep my workflow, our workflow, organized for future runs. Every workflow needs a clear finish line, and this one is it. After all the automation, the uploads, and all the processing, we're now closing the loop by marking the project as complete. This step updates our Google Sheet so that we can instantly see which videos are done and where their final links are stored without having to track anything manually. So we'll add a Google Sheets node and then set the operation to update row. Then choose the same spreadsheet that we've been using for long-form video tracking, and under sheet name, select sheet 1. Next, we'll tell the workflow how to find the right entry. So we'll set the column to match on to title and map it to the title field from the Get Ideas node. Now, you'll see this connection clearly here on your screen. Now we'll simplify the column so that only production status and final output remain. So for production status, we'll set the value to done to indicate the project's completion. For final output, we'll link the video URL from the download video node. Now this will automatically add that final link to our sheet. And once all of that is configured, again, we'll just click execute step and then make sure to check our sheet, and we should see the project marked as complete with its video link right beside it. Once again, we'll rename this node update final output to keep everything clean and easy to follow for future runs. And that's it. We've gone from a single spreadsheet idea all the way to a fully generated, edited, and uploaded YouTube video without ever touching a timeline. Every step from prompt creation to final publishing all runs automatically once we hit execute. And you can try expanding this for different formats, styles, or even multiple channels. I want to thank you for watching, and if you want to see how to scale this even further, stick around and subscribe. Got more coming up next.